Okay, hi everyone, welcome back to this video series on the Comptia Security Plus course, Authentication Models and Components. Now that we've covered some physical authentication methods, let's move into authentication models, components and technologies used to grant or deny access to operating systems and computer networks. The first thing a security administrator should do is plan what type of authentication model to use, then consider what type of authentication technology and how many factors of authentication will be implemented. Also for consideration is how the authentication system will be monitored and logged. Getting more into the specifics, will only local authentication be necessary, or will remote authentication also be needed, and which type of technology should be utilized? Will it be Windows based or third-party solution? Let's discuss these concepts now and give some different examples of the possible solutions you can implement. Authentication models. Many small businesses and even some mid-sized businesses often have one type of authentication to gain access to a computer network, the username and password. In today's security conscious world, this is not enough for the average organization. Some companies share passwords or fail to enforce password complexity. In addition, password cracking programs are becoming more and more powerful and work much more quickly than they did just 5 years ago, making the username and password authentication scheme limiting. Not to say that it shouldn't be, but perhaps it should be enforced, enhanced and integrated with other technologies. Because of the limitations of a single type of authentication such as username and passwords, organizations sometimes use multiple factors of authentication. Multi-factor authentication, MFA, is when two or more types of authentication are used for user access control. For example, a multi-factor authentication would be when a user needs to sign in with a username and password and swipe some type of smart card or use some type of other physical token. At the same time, adding factors of authentication make it more difficult for a malicious person to gain access to a computer network or an individual computer system. Sometimes an organization uses 3 factors of authentication, perhaps a smart card, biometrics and a username password. The disadvantages of a multi-factor authentication scheme are that users need to remember more information and remember to bring more identification with them, and more it costs and more administration will be involved. Another disadvantage of some MFA environments is that they are static rules and whitelists. Blacklists are usually configured manually. A more dynamic way of authenticating individuals is to utilize context-aware authentication, also known as context-sensitive access. It's an adaptive way of authenticating users based on their usage of resources and the confidence that the system has in the user. It can automatically increase the level of authentication required and or increase or decrease the level of access to resources based on constant analysis of the user. Some organizations have several computer systems that an individual user might need access to. By default, each of these systems will have a separate login. It can be difficult for users to remember the various logins. Single sign-on, SSO, is when a user can log in once but gain access to multiple systems without being asked to log in again. This is complemented by single sign-off, which is basically the reverse. Logging off signs off a person from multiple systems. Single sign-on is meant to reduce password fatigue or password chaos, when a person can become confused and possibly even disorientated when having to log in with several different usernames and passwords. It's also meant to reduce IT help desk calls and password resets. By implementing a more centralized authentication scheme such as single sign-on, many companies have reduced IT costs significantly. If implemented properly, single sign-on can also reduce phishing in large networks and enterprise scenarios. It might not be possible for users to have a single sign-on, and in these cases it might be referred to as reduced sign-on. Single sign-on can be Kerberos based, integrated with Windows authentication, or token or smart card based. SSO is a derivative of Federal Identity Management, also called FIM or FIDM. This is when a user's identity as well as a user's attributes is shared across multiple identity management systems. These various systems can be owned by one organization. For example, Microsoft offers the Forefront Identity Manager software, which can control user accounts across local and cloud environments. Also, Google, Yahoo and Amazon are examples of companies that utilize this federation approach, but some providers join forces so that information can be shared across multiple services and environments between the companies, yet still allow the user a single sign-on. Shibboleth is an example of an SSO system that allows people to sign in with a single digital identity and connect to various systems run by federations of different organizations. SSO systems and federated systems in general will often incorporate the concept of transitive trust, where two networks or more have a relationship such that users logging into one network get access to data on the other. While an SSO is easier for the user to remember, it acts as a single point of failure as well. In addition, sometimes a company might not be watching out for the user's best interests, either unwittingly or otherwise, and might fail to realize that multiple systems have been configured in a transitive trust. We mentioned the transitive trust concept in Chapter 7, Networking Protocols and Threats. When it comes to authentication, it can be especially damaging. Let's say that a user has an account with company A and has a separate account with company B. Imagine that company A and company B have a two-way trust. Now let's say there is a third organization, company C, that has a two-way trust with company B. At this point, the user's account information from companies A and B could be shared with company C, even though the user never signed up with that company. This kind of activity is frowned upon, but the user might not even know when it happens. Two companies might merge, or a company might be bought out or otherwise absorbed by another. So when it comes to authentication, it is sometimes wise to avoid trust relationships and strongly consider whether single sign-on will ultimately be more beneficial or costly to your organization. Another concern is web-based SSO. Web-based SSO can be problematic due to disparate proprietary technologies. To help alleviate this problem, the XML-based security assertion markup language SAML and the OpenID Connect protocol were developed. OpenID Connect is an interoperable authentication protocol based on the OAuth 2.0 family of specifications. It uses straightforward REST JSON message flows with a design goal of making simple things simple and complicated things possible. Both OpenID Connect and SAML specify separate roles for the user. The service provider and the identity provider shibboleth is also based on SAML. Whatever the type of authentication scheme used, it needs to be monitored periodically to make sure that it's working properly. The authentication system should block people who cannot furnish proper identification and should allow access to people who do have proper authentication. Let's talk about some of these authentication technologies now. Localized authentication technologies. There are several types of technologies for authentication a user on a local area network. Examples that are software based include LDAP and Kerberos, where as an example that includes physical characteristics would be 802.1x. Keep in mind that there is a grey area between localized and remote authentication technologies. I've placed each technology in the category in which it is used the most commonly. During this section and the next one, we mention several encryption concepts that work with the various authentication technologies. These encryption concepts and protocols are covered in detail chapter 14 and 15 PKI and encryption protocols. 802.1x and EAP. 802.1x is an IEEE standard that defines port-based network access control (PNAC), not to be confused with 802.11x WLAN standards. 802.1x is a data link layer authentication technology used to connect hosts to a LAN or WLAN. 802.1x allows you to apply a security control that ties physical ports to end device MAC addresses and prevents additional devices from being connected to the network. It's a good way of implementing port security, much better than simply setting up MAC filtering. It all starts with the central connecting device, such as a switch or wireless access point. These devices must first enable 802.1x connections. They must have the 802.1x protocol and supporting protocols installed. Vendors that offer 802.1x compliant devices, for example switches and wireless access points, include Cisco, Symbol Technologies and Intel. Next, the client computer needs to have an operating system or additional software that supports 802.1x. The client computer is known as a supplicant. All recent Windows versions support 802.1x. Mac OS X offers support as well, and Linux computers can use Open1x to enable client access to networks that require 802.1x authentication. 802.1x encapsulates the extensible authentication protocol EAP over wired or wireless connections. EAP is not an authentication mechanism in itself, but instead defines message formats. 802.1x is the authentication mechanism and defines how EAP is encapsulated within messages. An example of an 802.1x enabled network adapter is shown in figure 10.1. In the figure, you can see that the box for enabling 802.1x has been checked and that the type of network authentication method for 802.1x is EAP, specifically protected EAP-PEAP. Following are three components to an 802.1x connection. Supplicant, a software client running on a workstation. This is also known as an authentication agent. Authenticator, a wireless access point or switch authentication server. An authentication database, most likely a Radius server. The typical 802.1x authentication procedure has 4 steps. The components used in these illustration steps are illustrated in figure 10.2. Figure 10.2, components of a typical 802.1x authentication procedure. Step 1, initialization. If a switch or wireless access point detects a new supplicant, the port connection enables port 802.1x traffic. Other types of traffic are dropped. Step 2, initiation. The authenticator, switch or wireless access point periodically sends EAP requests to a MAC address on the network. The supplicant listens for this address and sends an EAP response that might include a user ID or other similar information. The authenticator encapsulates this response and sends it to the authentication server. Step 3, negotiation. The authentication server then sends a reply to the authenticator. The authentication server specifies which EAP method to use. Then the authenticator transmits that request to the supplicant. Step 4. Authentication. If the supplicant and the authentication server agree on an EAP method, the two transmit until there is either success or failure to authenticate the supplicant computer. Following are several types of EAP authentication. EAP MD5. This is a challenge-based authentication providing basic EAP support. It enables only one-way authentication and not manual authentication. EAP-TLS. This version uses transport layer security, which is a certificate-based system that does enable mutual authentication. This does not work well in enterprise scenarios because certificates must be configured or managed on the client side and server side. EAP-TTLS. This version is tunneled transport layer security and is basically the same as TLS, except that it is done through an encrypted channel and it requires only server side certificates. EAP-FAST. This uses a protected access credential instead of a certificate to achieve mutual authentication. FAST stands for Flexible Authentication via Secure Tunneling, PEAP. This is the Protected Extensible Authentication Protocol, also known as Protected EAP. This uses MS CHAP version v2, which supports authentication via Microsoft Active Directory databases. It competes with EAP-TTLS and includes legacy password-based protocols. It creates a TLS tunnel by acquiring a public key infrastructure PKI certificate from a server known as a Certificate Authority CA. The TLS tunnel protects user authentication much like EAP-TTLS. LDAP. The Lightweight Directory Access Protocol, LDAP, is an application layer protocol used for accessing and modifying directory services data. It is part of the TCP/IP suite originally used in WAN connections. It has developed over time into a protocol commonly used by services such as Microsoft Active Directory on Windows Server domain controllers. LDAP acts as the protocol that controls the directory service. This is the service that organizes the user's computers and other objects within Active Directory. An example of the Active Directory is shown in figure 10.3. Take note of the list of users known as objects of the Active Directory from the users folder that is highlighted. Also observe other folders such as computers that house other objects such as Windows clients. A Microsoft server that has Active Directory and LDAP running will have inbound port 389 open by default to protect Active Directory from being tampered with. Secure LDAP can also known as LDAPS. This brings into play SSL, Secure Sockets layer, on top of LDAP and uses inbound port 636 by default. Other implementations of LDAP use TLS, Transport Layer Security over LDAP. Kerberos and mutual authentication. Kerberos is an authentication protocol designed at MIT that enables computers to prove their identity to each other in a secure manner. It is used often in a client-server environment. The client and the server both verify each other's identity. This is known as two-way authentication or mutual authentication. Often, Kerberos protects a network server from illegitimate login attempts, just as the mythical three-headed guard dog of the same name, also known as Cerberus, guards Hades. A common implementation of Kerberos occurs when a user logs onto a Microsoft domain. The domain controller in the Microsoft domain is known as the Key Distribution Center, KDC. The server works with tickets that prove the identity of users. The KDC is composed of two logical parts: the authentication server and the ticket granting server. Basically, a client attempts to authenticate itself to the authentication server portion of the KDC. When it does so successfully, the client receives a ticket. This is actually a ticket to get other tickets, known as a ticket granting ticket, TGT. The client uses this primarily ticket to demonstrate its identity to a ticket granting server in the hopes of ultimately getting access to a service. For example, making a connection to the Active Directory of a domain controller. The domain controller running Kerberos will have inbound port 88 open to the service log on requests from clients. Figure 10.4 shows a netstat and command run on a Windows server that has been promoted to a domain controller. It points out port 88 used by Kerberos and port 389 used by LDAP on the same domain controller. Kerberos is designed to protect against replay attacks and eavesdropping. One of the drawbacks of Kerberos is that it relies on a centralized server such as a domain controller. This can be a single point of failure. To alleviate this problem, secondary and tertiary domain controllers can be installed to keep a copy of the Active Directory and are available with no downtime in the case the first domain controller fails. Another possible issue is one of synchronicity. Time between the clients and the domain controller must be synchronized for Kerberos to work properly. If for some reason a client attempting to connect to a domain controller becomes desynchronized, it cannot complete the Kerberos authentication, and as an end result the user cannot log onto the domain. This can be fixed by logging on to the affected client locally and synchronizing the client's time to the domain controller by using the net time command. For example, to synchronize to the domain controller in figure 10.4, the command will be nettime 10.254.254.252/set. Afterwards, the client should be able to connect to the domain. Kerberos, like any authentication system, is vulnerable to attack. Older Windows operating systems that run or connect to Kerberos are vulnerable to privilege escalation attacks, and newer Windows operating systems are vulnerable to spoofing. Of course, Microsoft will quickly release updates for these kind of vulnerabilities as they are found, but for the security administrator who does not allow Windows Update to automatically update, it's important to review the CVEs for the Microsoft systems often. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.